Hi guys, this is Dr. B. Here is a list of, or a list, I'm sorry, here is a video detailing some explanations from your study guide. So please watch this video, review this, gentlemen. This is to help you be successful for your exam that's coming very, very soon. Iron, atomic family, full and noble gas configuration, Bohr model, Lewis dot structures, and whatnot. So the atomic family for iron is transition metals. The full configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Noble gas configuration will be argon, 4s2, 3d6. The Bohr model, as it is written on the periodic table. So you have your nucleus, 4 orbits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's on your first 2 orbits. Then on your third one, you're going to have a total of 14 electrons for the 3s2, 3p6, and then 3d6. 8, 9, 10, 11, 12, 13, 14. 4s2, so 2 on the last one. Lewis dot structure. So for this one, it depends on the charge. So if iron had a 2 plus charge, your Lewis dot would have Fe and then 2 dots around it. If it was a 3 plus charge, it would have iron with 3 dots around it. Fluorine, atomic family, halogens. 1s2, 2s2, 2p5. Noble gas configuration, helium, 2s2, 2p5. Bohr model, your nucleus in the center, 1, 2 orbits, and then 2 electrons on the first sphere, 1s2. Then your second orbital will have a total of 7. Lewis dot structure is going to be F with 7 valence electrons around it. Make sure you put them out correctly, please. Make sure you guys know all the atomic families, all the qualities, characteristics, know the examples, the medicine ones. Make sure you watch the videos that are posted in your Google Slides, because if not, then you're going to maybe miss on some questions. So yeah, know all these things, gentlemen. Atomic radius. Why does it increase from top to bottom on a group or family? You're adding a new orbital, which increases the distance from the nucleus to the valence shell. It decreases from left to right on a period because adding more protons to the nucleus and valence electrons increases the attraction of the nucleus to the valence shell, shrinking the atomic radius. Electronegativity, I won't do all of these. Electronegativity increases from left to right on a period because adding more protons to the nucleus increases the likelihood of attracting an electron. Why does it decrease from top to bottom? Because adding an orbital increases the atomic radius, which decreases the attraction of an electron to the nucleus. So the next two I will verbalize, so please pay attention. Noble gases have zero electronegativity because they have a full valence shell, and halogens are the most electronegative family because on their valence shell, on their valence orbital, or valence shell, they are one short of a full valence shell. Ionization energy increases from left to right in a period because increasing protons and electrons increases their attraction of the nucleus to the valence shell. What does this mean? So what? This means that more energy is needed to remove a valence electron. Why does it decrease from top to bottom? Because adding orbitals decreases the attraction of the valence shell to the nucleus, which means less energy is needed to remove a valence electron. Why do noble gases have the highest first ionization energy? Because they have a full valence shell. They're going to hold on to their electrons. Higher ionization energy, and why? Bromine versus, so it's bromine, not boron, bromine versus fluorine. Fluorine will have the higher ionization energy because it has fewer orbitals than bromine, which means there's a greater attraction of the valence shell to the nucleus. More energy is needed to remove a valence electron. Smaller atomic radius, and why? Calcium versus radium. Calcium has a smaller atomic radius because it has fewer orbitals than radium. Calculate the energy of blue light that has a wavelength of 455 nanometers. So calculate energy is my unknown. Wavelength is 455 nanometers. Needs to be in meters. So you can just do 455 times 10 to the negative 9 meters, or 4.55 times 10 to the negative 7 meters, or 0.123456 zeros, then meters. That's my knowns and unknowns. Energy is hc over lambda. That's my formula. Energy equals 6.626 times 10 to the negative 34 times 3 times 10 to the 8. Numerator, denominator, 0.000000455. 6.626 times 10 to the negative 34 times 3 times 10 to the 8 divided by 0.12. This equals 4.368 something, e negative 19. So 4.37 times 10 to the negative 19 joules. I don't know why I said it like that, but oh well. The numbers for radio stations correspond to the frequency. So for example, Kona 101.1, which I listen to, is actually 101.1 megahertz, which I already converted to hertz for you, so you don't have to worry about it. What is its wavelength? So I give you a frequency of 101150 hertz. Wavelength is lambda, so my equation is going to be C equals wavelength times lambda. Isolate to solve for wavelength, divide both sides by frequency. 3.00 times 10 to the 8 over 101150 equals wavelength. 3 times 10 to the 8 divided by 101150 equals, that's kind of cool. 2.96735 something meters. So what radio stations have different, radio waves have longer wavelengths. So remember that. 4 sig figs. So 2.967 meters. On that note, remember your relationship between energy and wavelength. Might be a good idea to know that. If energy is increased, frequency is decreased. Sorry. Excuse me. If energy is increased, frequency is increased, wavelength is decreased. So here, these have a frequency, certain frequency, and has a certain wavelength. So radio waves have a longer wavelength because they have a shorter frequency. A laser emits a light frequency of 4.15 times 10 to 14 hertz. So notice how light has a faster or has a more frequent frequency. So that is this symbol, nu. Calculate the energy. E equals Planck's constant times frequency, 6.626 times 10 to the negative 34 times 4.15 times 10 to the 14. (2.74979 E negative 19, 3 sig figs, 2.75 times 10 to the negative 19 joules. All right, guys, so please pay attention to this video, watch it, listen to it, take the notes, do your study guide, etc. Review that, look at your old notes, look at all your assignments, etc. Please. All right, if you have any questions, please let me know. Thanks.